afternoon, student. Welcome to 2022 academic year. I'm Selma Makili, your tutor for Natural Science and Health Education 2. My contact details, in case you need to get on hold with me, is 081 49 86 908. You can also reach me on my email address, which is selmanangulatoivo@gmail.com. Okay, to begin with, student, I would like to welcome you to the Natural Science and Health Education 2 presentation for the year 2022. I wish you all the best. I wish you to be hardworking, dedicated, and self-driven students. This presentation covers the subject content in brief and some general guidelines that I want everyone to keep in mind when preparing for the 2022 examinations. So, Natural Science and Health Education is a very long syllabus, and I did not cover every topics, but have only touched a few topics, and I want you to follow the slides. Maybe I will not finish all of them due to time, but just follow the slides, and where you don't understand, you can contact me and ask. The first topic that we are going to look at is speed, mass, and density. Here I want us to be able to interpret the velocity time graph. Like the graph that is shown there, it's a velocity time graph. It's showing an object moving, the journey of an object moving from point 0 to point C. Now you should be able to describe the sections of this graph. How is the object moving from 0 to A? How is it moving from A to B, and also from B to C? So you should be able to describe those sections of the journey. And similarly, you should be able also to describe, not to describe, but to draw the graph. Given a description of an object that is moving, you should be able to draw the graph to show how the object is moving. Okay. Now, if you are to look at that one, the object, when the object is at 0, the car is, the object or the car is at rest. That means it's not moving, because if you are to go back to the graph at 0 there, at 0, the object did not cover any velocity. It have not moved yet. The time is 0 and the velocity is also 0 there. So we say the object here is at rest or is stationary. Then during OA, the object is accelerating, and that is a positive acceleration from 0 to A. That is positive acceleration. And we can also describe that the object here is moving with a constant acceleration. When this part of the graph is a straight line, then we describe the journey as constant acceleration. Okay? Then we have AB. AB on the graph there, the car is moving with constant velocity. AB, the car here is moving with constant velocity. And at OA, we said here the object is moving with constant acceleration. When acceleration is constant, then the speed is increasing. The object is moving with an increase in speed. Then it's constant acceleration, and it's when the line is a straight line. Then here, constant velocity, that means the object is moving with the same velocity. And when the object is moving with constant velocity, there is no acceleration. The acceleration here is 0. Why? Because there is no increase in speed or there is no increase in velocity. Then we have section BC. Describe how the object is moving from B to C. Here the object is moving with a constant deceleration, a decrease in speed. You can see it's moving from 40 meter per second to 0 meter per second. It's a constant velocity, which is also known as negative acceleration. You can see the description there. It is decelerating, negative acceleration. And when the object is in this line C, then that object is at rest again, because it's in that line of 0 meter per second and also 0 second. It's not moving, it's stationary. So that's how we should be able to describe or to interpret velocity time graph. And vice versa, you must be able to draw this graph when you are given the necessary description or necessary information. Okay? Calculating acceleration and distance covered from the speed time graph. Now, if you are to go back to the graph, if you are to go back to this graph here, if the question asks you to calculate acceleration from the graph, we have that formula that we use to calculate acceleration, which is acceleration is equal to final velocity minus initial velocity divided by time. Change in velocity divided by time. That is final minus initial velocity divided by time. Now calculate acceleration on the graph. Then you go to that section. It's either OA, which is showing constant acceleration, or you go to AB, or you go to BC. Then you calculate acceleration. And remember, the acceleration, if you are to calculate acceleration for this section OA, it's going to give you a positive value, because this is what we call positive acceleration. If you are to calculate acceleration between A and B, here we said the object is moving with a constant velocity. Therefore, acceleration here is 0. So it will give you a 0 value. Then BC. This one, you can calculate acceleration using final velocity minus initial divided by time. And the value of your answer here, it will be negative, because this is a negative acceleration. So the formula for calculating acceleration is that one. So you just use the slope of the graph or the gradient of the graph, then you use the formula to calculate acceleration. Then how do we calculate distance covered on a speed time graph? Distance is calculated using the formula for the shape. You look at the shape under the graph. If that shape is a triangle, then you can calculate the distance using the formula for calculating the area of a triangle. If the shape under the graph is a trapezium, for example, then you can calculate distance covered using the formula for calculating the area of a trapezium. Let's go back to the graph. Now, for example, on this graph, if the question asks you to calculate the total distance covered from O to C, then you look at the shape. What is this shape under the graph? If you are not able to identify the shape, then you can divide the shape into other possible shapes. For example, you can divide it here to make this one shape, which is a triangle. You divide it again here at B straight to have the second one, which is a rectangle. And then you divide it there again to have the last shape, which is another triangle. Then you calculate the area for this triangle, the first triangle. You calculate the area of the rectangle. You calculate the area of the other shape, which is a triangle. Then you add them together. then that's how we calculate the total distance traveled on a speed time graph. But if you can be able, or if you are able to identify the shape, like straightforward, this is a trapezium, then you can calculate that distance using the formula for a trapezium, which is half times a plus b multiplied by height. So we don't use the formula for distance. We don't substitute distance from the formula for speed. That's what most of the students are doing. They just substitute, or they make distance subject of the formula, which is distance is equal to speed divided by time. That one is wrong. When it comes to the graph, that's not what we use. We use the formula for calculating the area of the shape. Okay, we move on to calculating weight from mass. How do you calculate weight? These two are related to each other. Weight and mass are related to each other. The formula for calculating weight is mass multiplied by gravitational field strength, or multiplied by gravity. We all know the value for gravity is 10 Newton per kg. So this is the formula that we can use, and you can make mass of this, the subject of the formula. Substitute for mass in that equation. When you are asked to calculate mass, you can use the formula mass is equal to weight divided by gravity. So this one is very straightforward, and it's just a matter of making what is asked the subject of the formula. Mass now, when you are calculating weight, mass must be in a kilogram, because this is the SI unit for mass. Okay, density. The definition for density, we know it. It's a mass per unit volume, short and sweet. And that, if you know the definition, automatically you know the formula for calculating density is mass per unit volume. That means mass divided by volume. Now, with density, we must be able to describe why some objects sink and some objects float on top of water in terms of density. Objects that sink underwater are those that have got a greater density than that of water. If the object have got a greater density than the density of water, we know that the density of water is 1 gram per cubic centimeter. Now, any object that have got a density greater than 1 gram per cubic centimeter, it will sink underwater. And any object that have got a density less than the density of water, which is 1 gram per cubic centimeter, it will float on top of water. So we must be able to describe floating and sinking in terms of density. Okay, we are moving on to finding density. We are going to describe how do we find the density of irregular shaped object. How do we find the density of a regular shaped object? So when we are looking at a regular shaped object, an example is a stone. A stone have got an irregular shape. Now, how do you find the density of a stone? You must be able to explain. If the question asks you to explain or to describe, you describe all the steps that are involved in determining the density of an irregular shaped object. You can either describe using a measuring cylinder or using a displacement can, because this method of finding the density of irregular shape is called displacement method. So describe or explain, and we should also be able to calculate. Given necessary information from a diagram or in a paragraph, in a statement, you should be able to calculate the density of irregular shaped objects. We are moving on to unit number 2, which is moment of force. What is moment? Moment is the turning effect of force, or one can describe or define it as the product of force applied and distance moved. The turning effect of force or the product of force applied over a certain distance. The formula for moment is moment is equal to force times distance. And remember that moment and work done have got some similarities. Moment and work done can be calculated using the same formula. The formula for work done, for moment, is the same formula we use to calculate work done. Force times distance. And the other similarity is that they are both having the same unit. They can be measured in the same unit, which is Newton meter. Force times distance, because force is measured in Newton, distance is measured in meter. Therefore, the unit for both of them is Newton meter. Now, what is the difference? Those are similarities, the similarities between moment and work done. Now, what are the differences? The differences is that there's only one difference, is that moment is a vector quantity, while work done is a scalar quantity. I hope we know the meaning of those two terms. What is a vector quantity and what is a scalar quantity? A vector quantity is a quantity that have got both magnitude and direction. Scalar quantity is a quantity that contains only the magnitude. It does not show us what the direction. So that means if you are to compare the two, moment and work done, moment is a vector quantity because it has the size, the magnitude, and direction. For example, 20 Newton meter, that is the magnitude. In which direction is that? Clockwise or anti-clockwise, that is the direction. But work done is only having the magnitude, 20 Newton meter. That is scalar quantity. There is no direction. Okay, energy. Definition for energy, we must be able to define energy, which is the ability for a body to do work. Sources of energy, we have a lot of them. Sources of energy, example of some of the sources of energy, we have solar energy, wind energy, hydro energy, nuclear energy, geothermal energy, and many others, etc., etc. Now, we should also be able to write the energy conversions. Energy conversions that takes place, for example, when a body is moving. Here I have an example. When a person is running, can you write the energy conversion? So the energy conversions are chemical energy, which is energy stored in the body, which is going to be converted to kinetic energy when the person start moving, plus heat energy. Now, when people are writing these conversions, they write with arrows everywhere. What does the arrow mean in this conversion? The arrow means this starting energy, chemical energy, is converted. The arrow means converted to. And then what is the meaning of this plus? Plus means kinetic energy. As the person moves, the movement of the person comes together with this heat. Their kinetic and heat energy are produced together. So we can't put the arrow between kinetic and heat. If you are to put the arrow here, you mean kinetic energy is also converted to heat energy, which is wrong. Kinetic and heat comes together. Therefore, we show that by putting a plus. Okay? Calculating kinetic energy and potential energy. We have formulas that we use to calculate kinetic energy and potential energy. For kinetic energy, the formula that we use is kinetic energy is equal to half multiplied by mass multiplied by velocity squared. Half multiplied by the mass of the object that is moving, then you multiply it by the velocity, at which velocity is that object moving. But that velocity must be squared. Majority of us, we always forget to square the velocity. So let's take note of that. And the formula for calculating potential energy is equal to mass multiplied by gravity multiplied by height. The mass of the object multiplied by the gravitational force or gravitational field force multiplied by the height. Okay? Then use kinetic theory to explain how energy is involved in the phase changes or in the phase state. This one is familiar to everyone. Phase changes, the change of state, for example, from solid to liquid. What is that change of state? The change of state from liquid to gas. How do you call that change state of state? I mean, the change of state from gas to liquid, from liquid to solid, and also from solid to gas. We should be able to explain how energy is involved in those change of states. Remember that a change of state from solid to liquid, and that from liquid to solid, they take in energy. For those melting and evaporation or boiling to take place, energy must be taken in. And it is that energy that is used by particles to vibrate or to move, and then a change of state takes place from solid to liquid or from liquid to gas. Then change of state from gas to liquid or from liquid to solid. These ones give out energy, because here you are cooling. Particles need to lose energy so that they move toward each other and then change from gas to liquid or from liquid to solid. Particles need to lose energy and then slowly start to move toward each other, build up the force of attraction between them until then they change from solid to liquid. Okay, we are moving on to unit 4, which is wave, light, water, and sound. We are going to look at water waves, light wave, and sound wave. What are the properties of waves in general? All waves can be reflected, can be refracted, and can also be diffracted. All the waves, these are properties of all waves. Can be light wave, water wave, or sound wave. They can be reflected, they can be refracted, and they can also be diffracted. Let's start with diffraction. Diffraction, what is it by definition? It's a bending of waves after passing through an obstacle, or after these waves pass through a gap. I have some diagrams here. The first diagram shows waves passing through a small gap or a narrow gap. And the second one is showing waves passing through a wider gap. Now you can see that after the waves pass through, they are going to be diffracted or they are going to be bent. But the bending effect is not the same for those waves that passes through a narrow gap and those that passes through a wider gap. The bending is not the same. Waves that are passing through a narrow gap, they are diffracted more. That's why you can see that they are circular. Circular waves after passing through a gap, that means the diffraction was greater or it was more. And if you are to look at the second diagram, here the diffraction is less. These waves are diffracted less. Why? Because they only curve toward the edge and they are still straight in the middle. So you must be able to compare between the two gaps, which one diffract the waves most and which one diffract the waves the least. And you should also be able to draw these diagrams. Okay, we are moving on to refraction of waves. What is it? It's the bending of waves when moving in a medium of different densities. For example, water waves moving from shallow to deep, or from deep to shallow. you can see here I have an example here of water waves moving from shallow to, moving from deep to shallow. They are being diffracted. And these waves, they are approaching the barrier at an angle. They are not straight. Therefore, when they are going to be refracted, they are going to change the direction. The direction is not going to be the same because the approaching waves, they approach the barrier at an angle. So when they are going to be refracted, they are also going to be refracted at an angle, and that will make them to change their direction. So you should be able to describe how are these waves refracted from shallow to deep or from deep to shallow. From deep to shallow, if they are refracted at an angle, they are going to be refracted away from the normal line. And if they are diffracted not diffracted but refracted, straight waves approaching a straight barrier, then they are also going to be sent back, or they are going to not to be sent back, but they are going to be refracted in the same direction. Okay, constructing, this is light wave now, constructing a ray diagram to show the nature, position, and properties of the images formed on a thin converging lens. Now, when we are drawing these diagrams, we should take note of two things. Ray diagrams to show how the image, to show the nature, the position, and properties of image formed by a thin converging lens. The arrow here in the middle here represents the lens, which is the converging lens. Now you have the object here on the left hand side. It's labeled below the O. O stands for object. This is the object. Now for the image of this object to be formed, there are two rays moving from the top of the object. There is this ray, we call this ray a parallel ray. It's parallel to the principal axis. That's why it's called parallel ray. It goes parallel straight from the top of the object toward the lens. And when it gets in the lens, it's going to be bent. And you can see that it's bent or refracted, and it passes through this point. The first point, the focal point, just from the lens, that point, always when this ray is refracted, it's going to pass through that point. It's a must. So when you are drawing that ray from the lens, refracted, then pass through that point, then it goes straight. Then the second ray is called the central ray. It is this ray again coming from the top of the object. And this one, it goes straight through the lens. It's not refracted. It's not bent. So you draw it through using a ruler, it passes straight through the center of the lens, then it goes straight. Now, the point where the two rays intersect, those two rays are going to intersect. Where they are going to intersect, that's where the image is formed. So our image here is there, and you can see it's labeled I. Now, where is this image? The position of this image is between F and the 2F, on the other side of the lens, between F and the 2F. Now, what are the nature, or what are the characteristics or the properties of this image between F and the 2F? The characteristics are here. The image is real, the image is inverted, and is smaller than the object. Why is this object real? A real image are formed when rays passes through the lens. So for example here, these two rays, the central and the parallel ray, they passes through the lens. So any image that is formed when rays passes through the lens, we call those image the real image. Then the image is inverted. What is the meaning of inverted? That means the image is upside down as compared to the what? To the object. The object is upright, but the image formed on the other side is inverted, or it is upside down. Then the other property or characteristic is that the image is smaller than the object. You can see it's smaller there. So we have other diagram here. I have only included one diagram, the ray diagram. But if you go to your study guide, these diagrams are there. They show you how to draw these rays, how to locate the position of the image, and they are also the properties or the nature or characteristics of this image. So you go through and then be able to draw those ray diagrams. Electromagnetic spectra. This is a range of wavelengths or frequencies over which electromagnetic radiation extends. So we have the diagram here, which shows different examples of different types of electromagnetic waves. So we have gamma rays, X-rays, UV rays, visible light, infrared, microwave, radio, and TV waves. So you can see, if you are to compare the wavelength from the left, that is from the side of gamma rays to radio wave, you can see that gamma rays have got the shortest wavelength. From gamma rays to radio wave, the wavelength increases. Gamma rays have got the shortest wavelength, and the radio wave have got the longest wavelength. Again, here from the left, the frequency. Gamma rays have got the highest frequency because it have got a greater amplitude. Frequency is associated with the amplitude. The greater the amplitude, the higher the frequency. So gamma ray is having the highest frequency, and it's decreasing from left to right. Radio wave have got the lowest frequency because it have got a smaller amplitude. So these are examples of electromagnetic waves. So you must be able to draw diagram to show their frequencies and also their wavelength, and also give the examples. The examples are given here below the diagram. So you should be able also to give the examples where they are used. Okay, we are moving on to Unit 5, Electricity and Magnetism. Static electricity and electric current. By definition, we should be able to give the difference between static electricity and electric current. What is static electricity? We describe static electricity as electricity that does not move. And we describe electric current as current or electricity that moves or that flows. It can flow from one terminal to the other. So this is the definition for static electricity, electricity that does not move. How is it produced? How does static electricity, how do we produce it? It's produced by rubbing or by friction. When you are rubbing two materials or two things together, between them there is friction, and then it results in charged surfaces or charged object. For example, here you can see an example here. We have a polyethylene rod. It's being rubbed by a cloth. These two materials are different, and remember they are made up of charges. When the number of charges, positive and negative charges, are equal on a material, we say that material is neutral. So before rubbing, the cloth is neutral and the polyethylene rod is also neutral. Now when you rub the polyethylene rod with a cloth, what are you doing? You are separating the charges. The negative charges are moving from the cloth to the polyethylene rod. And then at the end, the cloth will be positively charged because it will have more positive charge than the negative charge. And then the polyethylene rod is going to be negatively charged because it's going to have more negatives than the positive. Also, The other case scenario is this one, rubbing the acetate rod with a paper. You can see now here that electrons are moving from the rod to the paper, because these are different material from the previous one, the first one. Now when you rub acetate rod with a paper, now you are separating charges again. But in this case, charges, the negative charges are moving from the rod to the paper. At the end, the rod will be positively charged and the paper will be negatively charged. That's how we charge the object, by rubbing or by friction. You should also be able, be able to describe or understand how a gold leaf electroscope is used. It's used to detect charges, to detect whether the object is charged or not. So like here, we have a positively charged object brought closer to the disc of the electroscope. So you can see the disc of the electroscope here is negatively charged. Now, why is it charged? It was neutral before. Let's say it was neutral before. When you bring this rod closer to the metal cap, the instrument, the electroscope, was neutral. Now when you bring this rod, the positively charged rod, closer to the metal cap, then the positive charges which were there are repelled by these positive charges on the rod. So they run down at the bottom of the gold leaf, to the leaf and also to the stem or to the plate. That's where the positive charges are moving, because they are repairing those ones on the rod, leaving the metal cap or the disc with a negative charge only. Now, what does this mean? What we are going to observe here is that the gold leaf is going to lift up, showing that there is a repulsion, and showing also the charge which is on the rod that was brought closer to the disc. So we should study and understand how this gold leaf electroscope works. The description is here, or before we go to that, it says charging the electroscope. When you are charging the electroscope, you bring a positively charged plastic roller near the metal cap. The gold leaf diverge because the electrons are attracted to the roller. So electrons are attracted to the roller, and the positive charges are repelled by those positive charges on the roller. Then, bringing a negatively charged plastic near the metal cap, the gold leaf diverge again, because the electrons are repelled from the metal cap to the gold leaf. The gold leaf will be negatively charged. So if you are to bring a negatively charged roller or rod here next to the metal cap, then electrons will move to the bottom, to the gold leaf, to the metal plate, and also to the gold leaf. Why? Because the negative charge on the rod are being repelled by those ones on the instrument. Then make the gold leaf and the stem to be, or the plate to be, negatively charged. And then we are going to observe that the leaf is diverging, or is moving or repairing the stem. Current, we said current is electricity that moves, or is the rate of the flow of charge. Those are the electrons. Remember that electrons are the one that moves, not positive, because positive charges are closed inside the material. They are somewhere in between the material. So whenever you're talking of moving charges, the charges that are moving are the negative electrons. The unit in which current is measured is amperes. Potential difference of a source, we define it as the energy per unit charge. Potential energy of a source is energy per unit charge. Energy that is given to the charges so that those charges start moving. If this charge does not have energy, then they will not be able to move. So when you are talking of potential energy, potential difference, we are talking about energy that is given to the charge so that those charge will be able to move around the circuit, and it's measured in volts. And when you are connecting when we are measuring the potential difference, we measure it using the voltmeter, and the voltmeter is always connected in parallel. Current is measured using the instrument called ammeter, and the ammeter should always be connected in a series. Resistance is the opposition to the flow of charges. The formula for calculating resistance is voltage divided by current. You can make whatever is asked from this formula to make it the subject of the formula. For example, if you are asked to find voltage given current and resistance, so make voltage the subject of the formula, or you can be given voltage and resistance and be asked to find or to calculate current, so you make current the subject of the formula. Factors that affect resistance. What are the factors affecting resistance? Then the first one is the length of the conductor. Length of the conductor. The second one, we have cross-sectional area of the wire, which is also known as diameter. We have temperature, and we have type of material. Those are the factors that affect the resistance of the conductor. And we should be able to describe or explain how each of these factors affect the resistance of the conductor. For example, the first one, length of the conductor. How does it affect the resistance of that conductor? Resistance is directly proportional to the length of the wire. That means the longer the wire, the higher the resistance. Or the shorter the wire, the lower the resistance. That means if you make the conductor, the wire where current is flowing, if you make it longer, the resistance will also increase. When you increase the length of the wire, resistance also increase. If you decrease the length of the wire, making it shorter, then resistance will also decrease. Those two, resistance and length of the conductor, they are directly proportional to each other. That means when one increase, the other one also increase. So you should be able to describe that they are directly proportional to each other. What do you mean by that? When the length of the conductor increase, the resistance also increase. Or you can say when the length of the conductor decrease, resistance also decrease. The second one, cross-sectional area, which is also known as diameter. How does it affect the resistance of the wire? Resistance of a wire is inversely proportional to its cross-sectional area, or to the thickness, or to the radius, or the diameter. All those terms applies to the cross-sectional area. That means the bigger the diameter, or the bigger the cross-sectional area of the wire, the lower the resistance. If you use a thicker wire have got a greater cross-sectional area, or it have a greater diameter. Now, what will happen to the resistance? When the diameter increase, the resistance will decrease. When the diameter decrease, making the diameter smaller, the resistance will increase. They are inversely proportional. That means when one increase, when the diameter increase, the resistance will decrease. When the diameter decrease, the resistance will increase. They are inversely proportional. When one increase, the other one decrease. You can see at the diagram here. This one have got a smaller diameter or cross-sectional area. So resistance in this wire is going to be greater, or it's going to increase, because the diameter is decreased, so the resistance will increase. This one have got a greater diameter, so the resistance will be decreased. Temperature. Resistance of a wire is directly proportional to the temperature. This one are directly proportional. It's just the same as the the length. When one increase, the other one also increase. Then type of material. The type of material, we know that some materials are good conductor of electricity and some are not. Those that are good conductor of electricity is because they have low resistance. And those that are bad conductor of electricity is because they have high resistance. Remember, resistance is the opposition to the flow of charges. If there is more resistance, that means charge are passing through with difficulties. It's because of that resistance. So we have some materials that are good conductor of current, is because, or electricity, is because they have low resistance. For example, nichrome wire, copper wire, and eureka wire. And we have other conductors like a light bulb. It's a bad conductor because it have got a higher resistance. So generator, simple AC generator. So we should know the principle of AC generator, and this is the diagram for AC generator, be able to describe how it works and know the structure of an AC generator. And this is the graph. You must be able to sketch this graph for an AC generator to show how current or voltage is produced. Student, time is limited. Time is not on our side. I'm not able to complete this presentation by looking at all the topics, but what I have included in this presentation, I have included all the slide with some explanation for all the topics. Can you please go and read? Where you don't understand, you can call me on my number. I have given you my number. I have given you my email. You can contact me even on my WhatsApp. We have a WhatsApp group. You can just pop up your questions there and we can discuss them. So I wish you all the best and study hard so that you can fulfill your dreams, and nothing comes on the silver plate. Remember, you have to work for everything. I thank you very much, and let's study hard.